Hello students, welcome back to the next module of this chapter, oscillation. Students, in the last module we have seen a very important concept of SHM as a projection of UCM on any diameter. In this module we will derive it mathematically. Students, a motion can be called as simple harmonic only when if we can prove either f proportional to minus x or acceleration proportional to minus x. Let us prove one of these two conditions in this module. So let's derive an expression for SHM as a projection of UCM on any diameter. So let us consider a particle which is performing UCM in anti-clockwise direction. Let omega be the constant angular velocity, and as you can see, let a be the radius of the circle. Students, let initially the particle be at position P0. So as you can see in the diagram, at t is equal to 0, the particle is taking the position P0. Let us join O and P, and you can see it makes an angle, say angle alpha, where alpha is the initial phase or epoch. Therefore, I can write, if you can see in the diagram, angle DOP. Yes, that angle DOP is equal to alpha. Let the particle further move to a position P in time t. Again, if I join, you can clearly see it makes an angle theta. Let's find the angle theta, students. Now, we know by the definition of angular velocity, omega is theta by t. Therefore, theta is equal to omega t. Let us substitute it here, and therefore I can write here as omega t. So students, that angle P0 OP can be written as, yes, it is equal to omega t. Therefore, the total angle DOP can be written as, yes students, the total angle becomes, that is omega t plus alpha. Let's move ahead in the derivation, students. Now, let's derive expression for displacement. Now, let's draw perpendicular from P to diameter AB. Let it represented by particle M. We know M is the projection of P on diameter AB. Let this OM be x, and this is nothing but displacement of the particle from the mean position. So, you can see in the diagram OD and PM are two parallel lines, and as seen in the diagram that OP is intersecting them. So, angle DOP, this angle, should be equal to angle PM. Reason? Yes, it is alternate angles. But you know angle DOP is omega t plus alpha. Therefore, my dear students, angle OPM is also omega t plus alpha. Now, let's consider that right angle triangle OMP. Students, can I write sine of that angle? Yes, what is sine? Definition. Sine of an angle is opposite side upon hypotenuse. Now look at the diagram. Can I say opposite is OM? Whereas the hypotenuse in the diagram is, students, yes, it is OP. OM is x and OP is nothing but radius of the circle, that is A, and hence students x is equal to, yes, it is A sine omega t plus alpha. Now, let's derive velocity. As we know, students, velocity is dx by dt, rate of change of displacement with respect to time. Now, let us substitute the value of x in the expression, and it becomes d by dt of a sine omega t plus alpha. Let's take a constant outside of the derivative, and it becomes a d by dt of sine omega t plus alpha. Students, we know the standard formula of this in differentiation is, yes, d by dx of sine kx plus c is constant out k, and sine derivative is cos, that is cos kx plus c. Therefore, our derivative d by dt of sine omega t plus alpha will become Omega is out constant and hence it becomes omega cos omega t plus alpha. We will substitute it here and hence the formula becomes V is equal to A omega cos omega t plus alpha. Let's move ahead. Let's go for acceleration, students. Acceleration is rate of change of velocity with respect to time. That is A is equal to dv by dt. Again we will substitute the value of V in this formula and I can write it as d by dt of A omega cos omega t plus alpha. Students, A omega is constant and hence it becomes d by dt of cos omega t plus alpha. Again, the standard form of this is d by dx of cos kx plus c is minus k sine of kx plus c. Therefore, d by dt of cos omega t plus alpha will become minus omega sine omega t plus alpha, and substituting it back we get it's minus omega sine omega t plus alpha. Therefore, acceleration on rearranging becomes, yes, minus omega square a sine omega t plus alpha. Let's take omega square out and in the brackets a sine omega t plus alpha. But students, a sine omega t plus alpha as seen is nothing but our equation 1 is the value is equal to x. Therefore, acceleration becomes minus omega square x. But since omega square is constant, I can write acceleration is proportional to minus x. Students, this is nothing but the condition for SHM. Now, can I say therefore we have proved that particle M which performs linear SHM, but we know M is the projection of P on diameter AB, and therefore we finally conclude that SHM is the projection of UCM on any diameter AB. That's all in this module.